welcome to episode 5 of Multivariable Physics. Sorry, I'm choking on water. Remember, this is part 2 of differential equations. So what I'm going to be talking about in this specific episode is I'm going to be talking about separating nonlinear equations. But the kind of main way to look at this is through the Bernoulli equation. So it's a very classic example, and I'm going to show you what this looks like. What is the Bernoulli equation? Well, the Bernoulli equation looks like this. We have y prime plus p times y is equal to g times y to the power of r. That's the Bernoulli equation. And then also we have the constraint that r is not equal to 0 or 1, because if it's either of those, then that is a first order linear equation which we can solve, right? Or it's separable. If it's 0, it's first order. If it's 1, it's easily separable. So we're interested in other numbers. So how can we solve this? So what we're going to do is we're going to turn this into a first order linear equation. And we want to do something very simple. So I'm just going to use this substitution here. Sum v is equal to y to the power 1 minus r. Right? And what does that give us? That's going to give us, if we take the derivative of that, that's just going to be 1 minus r y to the negative r y prime. And some people use n. Maybe I'll use n instead. To the power of n, rn, just so it's kind of more standard. Yes. So now now what do we do? Well, what we can do is we can actually go back and find, well, y prime is equal to y to the power of n v prime over 1 minus n. And so what we want to do is you actually want to just start substituting these values in here. So what I'm going to do is I'm going to take this and I'm going to turn it into that. So I'm going to go y to the power n v prime over 1 minus n plus p, okay, plus p v over, so y of y is just equal to v over y to the power of minus n, or actually is actually v y to the power of n, right? Because you divide by negative n. If you divide by negative n, that's multiplying by n, or y to the power of n on both sides to get rid of that. So we get this equation here. And so notice you have y to the power n on all sides. This can collapse, and this is going to turn into, well, this is going to turn into this v prime over 1 minus n plus p v equals g. And we know how to, and we should know how to solve this one. V prime plus 1 minus n p v equals 1 minus n times g. So we should all know how to solve this already, because I already talked about that. So let's do that. Let's go ahead and solve that. So we find the solution for v. V is equal to, and this is a bit long, but it's 1 minus n, actually e to the power of 1 minus n, integral p negative pt dt times 1 times this big integral of e to the power 1 minus n. And actually I'm going to put 1 minus n to the end there. It's pretty much just how we've solved it before. Just kind of got to substitute all this stuff in. I'm going to use green. So it's easier to see. And g of t dt. Right, and then we can reverse this and solve for y, right? And so we also remember we have that we have this relationship y 1 minus n equals v, so y is equal to the 1 minus nth root of v. So that is all of this. So all of this, it's going to be inside this little box. Right? And that's going to be our final solution here. So I think we actually need a plus c. I think we need a plus c for that v, and then yes, that's going to give us that solution. And that should be pretty much it. I think that's how you would solve the Bernoulli equation. So given this, you can solve it. Y equals 1 minus n, and it's going to be this big this really long integral, so that's actually n minus 1. This p dt there you go. Let's make that nice and colorful. And so that's going to be our solution to the Bernoulli equation. All right. So that was relatively quick. I think I did enough differential equations for now. I'm going to hop right into physics now, and we're actually going to start doing some physics stuff.